So it means, so what is your often over the transmission line? What about your underground cable? So we have discussed and how to calculate the transmission line parameters and how to evaluate but analyze the performance of our transmission line. Okay. So next we'll move on to the important but apart from that we are about the important common like insulator, what is insulator, how to but what about your string efficiency we have seen and what are the different types of towers we are using in our transmission and distribution system we have discussed. Okay. So today's session, we are going to see about our distribution system. We are going to see about our distribution system. Okay. So what is the often distribution system? What is the often distribution system? The power is going to be often generated at a generation station and it is going to be often stepped up and it is going to be often transmitted to the receiving and substation through the transmission system. Okay. Where it have often primary as well as often secondary transmission will be there. Then it will ends at your receiving substation. From there, remember the distribution system is going to be often start. Okay, so there will have often primary distribution as well as a secondary distribution. So if you see to that, remember the transmission and distribution system, this is going to be often similar to of our human circulatory system. Human circulatory system. So we can compare how the blood flows from your remember heart to of your lungs, lungs from lungs to of your again to of your heart. Okay, so likewise nothing, but if you take off the remember the transmission and distribution system is similar to of our circulatory system. Okay, so compared with the arteries, the human body and distribution systems are remember with your capillaries. So that's why remember how it's going to be living remember how that is going to be often main thing for our living. Right. Similarly, remember the electricity is going to be often important for the civilization. It means life giving for one civilization. So that's why. So in today's part of the power system, remember where the power is going to be often distributed to the consumer or the local, that is multiple, that is going to call us a distribution system. That is going to call us a distribution system. Okay. So I think in the structure of power system, in the structure of power system, we are seeing remember there will be often generation sessions will be there where the power is going to be often produced. That will be often nothing but so that will be of nothing but this is a transformer. We'll use often transformer to step up your voltages. After a transformer, we'll have often nothing but primary transmission, and then again will be often transformer will be there. Then again we will have of your secondary distribution, but secondary transmission will be there. Then we'll have often primary. Then we'll have often secondary distribution will be there. So this we are seeing about with respect of the structure of power system. Okay. So in that we are going to see the distribution part. We are going to see the distribution part. Okay, so in the distribution system, the main thing is going to appear as feeder, distributor, and serviceman. So this is going to happen very, very important. I think we have discussed the elaborately in the module 1. So anyhow, we will recap what is the of the feeders, distributor, as well as of your serviceman. What about your serviceman? Okay, so feeder is nothing but it's a conductor which connects the substation and neighbor to the area where the power is going to happen distributed. That's nothing but that is going to call us of your feeder. That is going to call us of your feeder. Suppose if you take off your nothing but you will have nothing but if you see in Vatakal Mandap, near to our college, we will have often two substations only there. One is going to have the receiving substation, other one is going to have our distribution substation. Okay, the remember the one is going to have 230 bar 110 kilowatt substation will be there. Another is going to have 110 bar 415 volt remember distribution transformer will be there. So they are nothing but that is both are adjacent. But one more thing where is remember is going to have remember one is going to have remember from 230 bar 110 substation, one feeder will go for the Kanatagaro. So that is going to called a substation feeder where that remember one substation will be there in Kanatagaro. So remember that is going to called a substation feeder. So feeder is a conductor which connects the substation to the area where the power is distributed. It means the area which is going to surrounded near to the Kanatagaro will be supplied from the substation of Kanatagaro. Okay. So generally there won't be no tapping from your feeder. So the current will be remains constant throughout here, but throughout the feeder. Okay. So here running, but the current carrying capacity is going to have the main consideration when you are designing of your feeders. Main consideration in the designing of your feeders. Okay. So what is your distributors? What is your distributors? So distributor is something what is a conductor. See here remember. So this is going to have our substation. This is going to have our substation. From substation, so many feeders is going to happen originate. So many feeders are going to happen originate. Okay, so that feeder is going to happen but connected to the local area where the power has to be often distributed. Suppose but you can able to see but from time but suppose you are living in your but in Malamchumti, you are near to your home or maybe of the next city, you can able to identify one transformer. So that transformer is that is going to be called a software distributor with that with respect to that area. Okay, so the distributor is going to have the conductor which tappings are taken for supplying to the consumer. So if you see in this diagram, nothing but AB is going to have one feeder, BC is one feeder, and nothing but CD is going to have one feeder, and DA or AD is going to have one distributor. Okay, so AB, BC, CD, and DA are going to have called a software distributor. In the distributor only nothing but there will be of nothing but the service means are going to be connected. Okay, so here since nothing but so many feeders are originate from your distribution substation, so nothing but the voltage or nothing but the current will not be uniform. Depends upon the load, the current is going to be often different. Depends upon the current that is going to happen nothing but it's going to happen different. Because that nothing but the tappings are going to happen taken at various places and the length is going to happen different. Okay, so that's why when you want to design up anything but distribution system, that too of a distributor, we have to maintain the voltage as often constant. That's why if you see nothing but three or more switches combined, one transformer will be there. Okay, so that to maintain the voltage is often constant. To maintain the voltage is often constant. As a statutory limit of voltage variation, it is allowed to often plus or minus 6%. Plus or minus 6% is going to have the allowable limit to vary. There is a standard limit. Within that, but we have to maintain the voltages often constant voltages. So what is the often service main? Okay, so with the substation, the feeders will be originated. That our feeders will be run through the length. Okay, the current will be constant throughout the feeder, but that is not in the case of your distributor. That is not in the case of distributor. Okay, so the distributor, the current won't be often constant because there will be often so many tappings will be there, and the length is also going to be often varying depends upon where the consumers. Okay, so that's why here while we are designing the distributor, the voltage should be maintained as often constant throughout the length. So it means it should not vary behind plus or minus 6%. Plus or minus 6%, below that, or above that, it should not get varied. Okay. So what is a service main? If you remember, is a small cable which connects the distributor to the consumer terminals. Okay, I think you can see you can see a pole near to your home. Okay, so from that one cable is going to have running to of your meter box. Service box, service connection. So that nothing but that is going to call the software service main, where the tapping is going to happen nothing but from tapping from the distributor to the home. So that is going to call the software service main. So this is the structure of our distribution system. This is the structure of our distribution system. Distribution system we have of your feeder, distributor, and service main. So this is very, very important. You have to remember it while studying about your distribution system. That's why I have very often recap what we are studied in our module 1. Okay. So how the distribution system is going to be often classified? How this distribution system is going to be often classified? Okay. So here one is going to have nature of current. Based on the nature of the current. So it means according to the nature of the current, the distribution system is going to be often classified as often AC distribution or it may be of your DC distribution system. So where you are needed with the DC system, we also provide the DC distribution system. Okay. So most preferably universally adapted distribution system is going to appear AC distribution system. Universally adapted distribution system is going to appear it's going to often AC distribution. Why? Because it's going to appear simple and as well as often more economical. Okay. Simple as well as appear more economical compared to of your AC distribution system. So that's why we universally we are preferring to go for often AC distribution system. Because the construction wise is going to be often simple and it is going to be often more economical compared to often DC distribution. But we cannot accept the one DC system should be used all the time. Where some of the points where we need often DC distribution system also. So that's why we are having often DC distribution system also. Okay, and second thing is nothing but depends upon the type of construction. It will be of an overhead system or it may be of an underground system. Okay, that depends upon the type of construction. The distribution system is going to be of an overhead distribution system or underground system. like nothing but it's going to be of nothing but normal nothing but rural area or maybe of nothing but the nothing but municipality or it may be of a corporation. We used to go for an overhead system where like metropolitan city or densely populated area where we cannot able to go for an overhead distribution system. There we used to prefer of an underground cables. There we will prefer of an underground systems. So that's why here I think, but our distribution system also is classified as of an overhead distribution system or it may be of a underground distribution system. Okay. And next thing is going to be on what basis the distribution system is going to be classified means nothing but scheme of connections. Okay. So actually number 3 is going to have the number 1, 2 and 5 is going to have the main classification. Okay. The next is going to have our scheme of connections. So scheme of connections is nothing but the based on the scheme, but the scheme how we are going to connect your consumer to the distribution system. Based on that, it will be often radial distribution system, ring or that is going to happen as a loop distribution system, and third thing is going to happen interconnected system. But here, if you want to see here, but each and every system has its own advantages and disadvantages. The scheme of connections, so it has its own disadvantages, advantages. Okay, so based on the applications, nothing but each thing has its own advantage and disadvantages. So apart from that, we can also classify the distribution system and depends upon the type of service and number of wires we are using. Okay, so type of service means but the distribution system whether it's going to happen for each for general lighting and power. It means suppose if some area we need to only but we have these often street lighting system. There we will use often but distribution system only is for often street light system. So exclusive type of service will have often railway system. Okay, railway system will have often separate electrification system where we have to provide often uninterrupted power supply. Okay, so that the railway tracking system that is going to often separate distribution system is there. Okay, so next industrial power distribution system depends upon the industrial type of industries. Okay, small scale industries or maybe if you have medium scale industry or larger industries, they will have their own scheme of distribution systems will be there. So that's why that is going to be classified based on the type of service. Okay, so type of service, but the distribution system is classified as often general lighting and power, industrial power distribution, railway power distribution, street light power distribution system. Like that, we can categorize based on the type of services. Okay, but depends upon the number of wires. The distribution systems are classified as often 2-wire, 3-wire, or 4-wire systems. Depends upon the number of wires. Our distribution systems are classified as often 2-wire. It means we have often phase and neutral in case of your AC. Okay, in case of DC means we have often positive and negative will be there. Okay, 3-wire system means remember we have often RYB. 3-wire system also we have often RYB. Same 3-wire system also we can use it in our DC distribution system also. So that we will see it in the upcoming slides. Okay. So next 4-wire system is we'll have often nothing but R phase, Y phase, and B phase with your neutral or maybe as your ground. So that is going to be your 4-wire system. Okay. So here we can classify the distribution system on based on 3 things. Mainly classified on distribution system based on 3 things. One is going to appear nature of your current. Next one is going to appear nature of your current. Second thing is going to appear type of construction. This based on the construction we can classify our distribution system. Third thing is going to appear scheme of connections. So apart from that, we can classify our distribution system. One is going to appear type of service and number of wires. Okay. So first we'll move on to the first important thing is going to appear AC distribution system. We'll move on to our AC distribution system. As I told you nothing but the power is going to be often received at the receiving substation. Okay. And there that is going to be often step down. From suppose the transmission voltage is going to be often 220 voltage. By using the step down transformer, that is going to be often step down to often 110 kilovolt, then that is going to be often transmitted to a distribution substation. Okay, so where fed by the transmission system and the consumer meeting, where will use often low voltage level. Okay, so that's why here the AC distribution system, the distribution is going to be classified often primary distribution system and as well as a secondary distribution system. That is going to be classified as often primary as well as a secondary. So this we have seen elaborately in our module 1 when we are discussing about the structure of power system. See, we'll recap once again. Okay. So here nothing but but larger blocks. It means but the industrial consumers or nothing but bulk consumers that will be connected only in the primary distribution system. Where that but they will use the voltage level of 11 kilovolt or 6.6 kilovolt or 33.3 kilovolts. So we are one of but if you take our institution, we are connected to our primary distribution system. Okay. So where we have our own secondary distribution systems, we are having it out. It means to distribute the power. It means we are connected to our primary distribution system because our voltage input voltage is going to often 22 kilovolt, where that is going to often but step down to often 415 volt at our substation. It means we are having our own substation arrangement. In there, we are going to step down at often voltage of 415 voltage. Okay. See here. So this is going to have our primary distribution system. This is going to have an AC primary system. Primary distribution systems will be. So from the generation station, we will have the power is going to often voltage is going to have stepped up, and the transmission starts at the receiving end. The transmission system is going to have an end. Okay, where we are having for the circular time, so here is the input voltage is going to often 33 kilovolt. At the substation, it is stepped down to often 11 kilovolt, and that 11 kilovolt is going to often distributed. So this distribution here is going to call as your primary distribution. It means from here it will be distributed to the various substations. This is your receiving substation. This is going to be called as your receiving substation, RS. This is going to call as a receiving substation, that is going to call as RS. So here from this feeder, that is we'll connect our big consumers like factory or maybe of your education institution that will be drawing the power from the primary distribution. Right? This primary distribution will connect the various substations. From this various substation only, the power is going to be often distributed to the individual consumers, where again the voltage is going to be often step down. So that is going to be called as your primary distribution system. That is going to be called as your primary distribution system. Okay. So, but the secondary distribution where nothing but sorry. So there is going to be secondary distribution where nothing is going to often further step down, and that is going to be often connected to our various consumers where the power is going to be often consumed, or utility consumer is going to be often connected to our secondary distribution system. So normally our secondary distribution system will be often 3-phase 4-way system. Okay, and the voltage level it may be of here 415 volt. If it's going to often single phase means it's going to often 230 volt. It will be for 3-phase means it will be often 415 volt. In case it's going to often single phase means it's going to often 230 volt. Okay, so normal that's why here most of our secondary distribution system will have often 3-phase 4-way system. So if some of the consumers will have often single phase supply, some of the consumers will have often 3-phase supply. So based on the requirement, then we can able to tap the energy from the secondary distribution very easy. So that's why here our secondary distribution system will have often 3-phase 4-way system. Okay, if it's 3-phase means we'll have often 415 volt. In case of single phase means we'll have often 230 volt. See, I think this diagram will give often more clear picture. How about your AC distribution system? That too with respect of an secondary distribution system. That too with respect of our secondary distribution system. If you see here, this is the transformer. So this transformer, so you can able to locate in your area or the street. So there we have a distribution transformer. So usually that distribution transformer will be often delta star connected transformer. It means in the primary side we use often delta connection, and the secondary side we use often star connected. That too the star is going to be often neutral grounded. That star is going to be often neutral grounded. So that only we can able to take often either even take often single phase or it may be often 3-phase supply also we can able to. So it means the input, it means from the primary distribution system. From the primary distribution system, one value but will go for upon nothing but but we'll get often substation. Distribution substation will get often DSS. So that is going to be called as often DSS. From this DSS, okay, one of the feeder is going to often originate to your area, and that will be often three phase. So that will connected to our distribution transformer, which is located in our street. Okay, so that transformer normally will be often three phase delta or star connected transformer, where that voltage is going to often step down from 11 kilovolt to often 400 kilo, 400 volt, 50 volt. Okay, so that but from that again the feeder is going to distributor is going to often originate. This is going to affect distributor. So this is a feeder, and here from the output of the transformer we have often distributor. This is going to affect distributor. So this distributor is going to often originate from the distributor. We are taking the service. So this is going to called as your service name. So I am having the house one. They are taken off a single phase supply. I am connecting from the B phase and the neutral. I am taking off this one. The house two, we are not going to connect in the same phase because the load should be uniform in your distribution system. It means each phase should have of an uniform load. Otherwise, unbalanced current will be flowing through your distribution system. So that leads to often frequent fault in our power system. To avoid that, to uniform load, so it depends upon the consumer load, then the phase is going to have a phase which is going to have draws will be often vary. So one house will be connected in B phase, another house will be connected in your Y phase, other house will be connected to often R phase. Suppose some of the house will be but they need often three phase supplements, it will be connected to often R, Y, B with neutral. Okay. So in the secondary distribution system also we have often factory load will be there, industry load. That may be of your commercial load where we have often small commercial complex, or maybe of your but you can have often nothing but small, or maybe of your but it may be of your small welding, but welding shop may be there, or it may be of anything but lathe factory will be there, machinery will be there. So those will be connected at our secondary distribution system, that too with three phase with lower voltage. So that also is going to be connected in our secondary distribution system. That is also going to be connected in our secondary distribution system. Okay. So this is how about our primary as well as our secondary distribution system. Any doubt? Any doubt? So today's session we have started with our distribution system. Okay. So distribution system means nothing but where nothing but the power is going to be often distributed to the consumers. So nothing but there is going to be the main part of our power system. That is going to be our main part of our power system. It means the distribution system is nothing but where it's going to distribute the power to of the local use. That is going to be called as of our distribution system. Here we are seeing what is the main important parts of our distribution system. So then generally we have a feeder, distributor, and as well as a service main. Okay, we can classify the distribution system based on three things. One is going to appear nature of current. Second thing is going to appear type of construction, and third thing is going to appear scheme of connection. So based on that, we can classify our distribution system. We can classify our distribution system. So first we have taken nothing but AC distribution system, because universally adapter system is going to have our AC distribution system. That too the secondary distribution system will use often AC, and that too often three phase 4-way system. Okay. So what is the primary distribution system we have seen, and what about our secondary distribution system we have seen? Okay, that too with respect to often AC distribution system. So now we'll move on to our DC distribution. Now we will move on to our DC distribution system. So we also need in our but the consumer we need of a DC distribution system also. But some of the applications where we need of variable speed machineries we are using, DC motors we are using for electrochemical work, or maybe of the congested area. So store the battery, we need of a DC supply. So there we need of a DC distribution system. So I think in your laboratory classes you have performed your DC experiments. Okay, so to understand the concept of DC machines where you can apply in your drives application. So you did your experiment on your DC machine. So there, but we are using a rectifier to convert your AC to often DC, then we are using for our application. So instead of that, we can also generate and the transmit and will distribute the power to of your distribution system. So but for the purpose of AC inhibit, that inhibit we can use of an inhibit conversion where we can convert the AC power to of an DC power, and nothing but we can supply for the various loads of DC loads, right? So but the electrochemical work is but we are doing of nothing but painting. Even in the car manufacturing industry, they will use of an electrochemical painting of your entire car. So there we need of a DC supply. Okay, got it. Or some of the applications we need, but the drives application we need often but DC power supply because the DC drive is going to have more preferred compared of an AC drive. So then we need of a DC distribution system. So then normally the DC supply from the substation may be obtained in terms of two-wire system or maybe of a three-wire distribution system. Okay, so if in the earlier days what we used to know, we convert the AC into of a DC through of your rectifier system, where initially we use of a electric rectifier, then we started with respect of motor generator set to generate the DC power. Okay. So two-wire system means nothing but, so we'll have often positive and negative that is going to often connected to of the various loads or maybe a motor. So that is going to appear two-wire system. So three-wire system means we'll have often neutral. We'll have of your neutral wire will be there. Okay. So that is going to appear two-wire system. That is going to appear two-wire system. It means positive and negative between that the voltage is going to happen two V because two to appear neutral wire. So we will see that how about our two-wire as well as our three-wire system. So two-wire system means nothing but we'll have often outer and as well as often two outer and a middle or maybe of a neutral wire. So that is going to happen earth at our substation. So automatically the voltage will be of your twice. Actually this is going to be for three-wire system. Sorry, made it wrong. So this is going to be of my three-wire system. Okay. So there will be of nothing but three-wire system. We'll have often three wires will be there. Okay. So one is going to appear neutral, nothing but two will be but the middle or that is going to cut off a neutral wire that is going to have a gap with respect of a substation. Okay. There will be of two wires will be in the outer. Okay. So the voltage here is going to have nothing but twice the voltages. So normally nothing but the load which needs of higher voltages will be connected at the outer circuit, where the load is going to have needs the lesser voltages that will be connected in the one outer and the inner part. So then even like lamp load or maybe the heating circuit, the DC voltage where it needs often smaller voltage, then that will be connected as often positive and the neutral and maybe a area. Okay. So how to generate our DC three-phase DC? So that may be generated by using often two generator method or three-wire generator method or balancer set or maybe a balancer set. So based on that, we can able to generate the power with your three-wire system. Here. So two-wire systems we use often two generators. We use often two generators. Okay, DC generators. We'll use often DC generators to generate our power. So this is generator one and generator. This is going to often field. Field is going to often excited. So when mechanical power is given to of your armature, then the inverter that is going to often rotate and catch the magnetic lines of force and EMF is going to often induce. So there we are going to convert figure. The negative is going to often we are having a technique of common ground. Okay. So the circulating current will be flows through of your neutral wire. Okay. So the positive is going to be connected to the load and one is going to be connected to of your neutral ground. Similarly, the other generator will be generating the power and negative, we are taking the negative power and that is going to be connected to of the other load. Okay. So here, when you are using of a two-wire system means this is going to have your two-wire. If you want to use of a two-wire, we need of a two generator. That common point is going to have connected to of your neutral. Common point will be connected to of your neutral. Okay. Where the circulating current or maybe of the difference current will be flowing through of your neutral point. So if you take between this point, so this voltage is going to be often V. So if you take the voltage between this point and as well as often this point, the voltage will be equal to often 2V. Twice the voltage will be appear between this point. Okay. So one of the main disadvantage when you are going for often two generator method means, but we need often two generator to produce the power. Okay. We can convert our AC power by using of a rectifier, then we can supply the DC power, or we can generate the DC supply also. Okay, we can generate the DC supply also. Okay, so in that we'll use of a DC two-wire system or DC three-wire system. DC two-wire system, or it may be of a DC three-wire system. Okay, so two-wire system means one is going to have an outgoing, or that is going to have called as our passive wire, and other one will be called as our return wire. Other one is going to called as our return wire. How we are seeing about in our HVDC system in the model one, same similar type. Okay, we have one positive as well as a negative. So one is going to have a positive, another one is going to have negative. That negative may be called as our return. Okay, so but normally the load and motor will be connected parallel. Okay, suppose if the larger application get double the voltage increment, that will be connected between the points with the neutral wire. So that become often three-wire system. That become often three-wire system. So now we are seeing that how to obtain the three-wire DC system. Okay, how to obtain the three-wire DC system. Okay, so there nothing but we can use often two generators. Okay, where we can use often two generators to generate the power. Okay, to obtain often three-wire system. அப்போ எப்படி இருக்கும் பார்த்தீங்கன்னா you can see this number. Suppose I am having of an armature. ஒரே ஜென்ரேட்டர்லையும் நம்ம வந்து இது பண்ண முடியும். நம்ம ஒரே ஜென்ரேட்டர் வச்சும் நம்ம வந்து பார்த்தீங்கன்னா we can able to generate அப்படி, but we can bring it out with the supply. இதோட ரீஃபரன்ஸ் எப்படி இருக்குன்னு பார்த்தீங்கன்னா will have of a field winding. Assume this is going to be of my generator. Assume this is going to be of my generator. I am taking a lead. Okay. One is going to be of my positive terminal. Other one is going to be of my negative terminal. Other one is going to be of my negative terminal. I am having of my field. Okay. So if I connect this point, okay, if I tap the power between this one, if I tap the power between this point, so this is become often B. Okay, this is become often B. Okay, this is become often B. Suppose if I tap between here to here, this value become often 2B. So here this is going to have called as a neutral ground. Sorry, I will present it. So we will have one generator. Okay, armature will be there. From the armature, we are telling that the commutator, we are going to take the tapping. Okay, we have one field winding will be there. So if you tap this common point, between this common point, if you tap, this voltage is going to be upon V. And if you tap between this one and this one, this become upon 2V. This become upon 2V. Okay, so the difference of the current will be, load current will be close to the neutral wire. Okay, so one of the main disadvantage when using a two generator method is we need to go for often two generators. So that is one of the main disadvantages when you are using often two wire system, two generator method. Okay, second thing is going to occur. three-wire generator. Second thing is going to be our three-wire generator. Okay, so here the three-wire generator, here nothing but, so the generator will be developed. Okay, so where the two-wire machines, one or two coils will be there with high reactance and the low resistance, high reactance and the low resistance. Okay, so that is going to be often connected permanently to the, that will be connected permanently to the diameter of the, means you are connected to of your armature. It means opposite to of your armature. Okay, so this neutral wire is going to often obtained from this common point. So that is going to have called the software three-wire system. Okay, so nothing but there will be of nothing but standard two-wire machines use with one or two coils, which we are going to have often high reactance and the low resistance. So that will be connected to the opposite point of our armature winding. So from that, the center point, from that we are going to set up the center point. That point will be access of your neutral wire. That point will be access of your neutral wire. So where we can use only one generator, so that we can able to produce the power with single generator. So that is one of the advantage when it comes to respect of an three-wire system, three-wire DC generator. Okay. So apart from that, we can use of a balanced system. Okay, we can use of a balanced system. In the balanced set, nothing but, so there will be of nothing but, we'll have of nothing but balancer will be there. Okay, we'll have of a balancer. So that balancer here, nothing but that will be, suppose you see here, we are going to use of this one. What is the third thing is going to be of a, but balancer set. The balancer set means we'll have of a generator. The generator will be often like this. Okay, so we'll have of a number. Tappings will be there. Okay, this is going to our generator, and this is a positive, and this is our negative. Okay, so we'll have often balancer will be there. We'll have often balancer will be there like this. We have often balancer like this. Okay, so here the voltage the voltage will be often 2V. So the voltage will be often 2V at this point. So here this is going to be often grounded. This is going to be often grounded. Okay. So from this point we can take out voltages. So when you are connecting here, the outer this point, so this is going to be of your volt. Suppose current we can able to tap the current from this point. Okay, or during this point also we can connect. There is A point and this is going to be a B point we can connect. Okay, suppose in case if you want to voltage completely, you can connect to an outer to outer. This is going to call the software balancer. This is going to call the software balancer set. Okay, so it means nothing but the generator will supply the power to the whole system. Okay. Identical two machines now, but coupled mechanically, where the armature and the field windings will be joined in series, where the armature and the field winding will be joined in series. Okay, across the outer. So junction of the armature will be earth, then automatically the neutral wire is going to be taken out from that one. Okay, so this is going to call the software balancer set. This is going to call the software balancer set. Okay. So I think we are seeing about what is the advantages of an invert overhead system as well as of an underground system. Okay, so it depends upon the public safety. We can go for an underground system, and depends upon your flexibility. You can go for an AC system, or if you want to avoid the fault, then you can go for an AC overhead system or AC underground system. So we can able to compare our underground system as well as an overhead system for the distribution system also. So based on the various factors such as going to happen public safety, or maybe of your initial cost, your flexibility, or maybe of your fault or fault location and repair, how about your repair, and how about the current carrying capacity and the voltage drop, and how about the interference with your communication circuits. So based on that, we can have of nothing but advantages and disadvantages of your AC distribution system as well as of your DC distribution system. Okay, so now we move on to the important thing. I think nothing but the upcoming before the the DC distribution system we have seen about only, but the scheme of connections. Okay, distribution system is going to happen. I think this is the thing which I have shown here. See here, the distribution system is going to happen classified and based on your scheme of connection. Based on your scheme of connection, it means all the distribution, whatever the energy is going to be often done for often constant voltages, this distribution system number, the scheme of connection is going to be often, generally we are going to use it of. Either it may be often radial distribution system or ring or loop system, or it may be of your interconnected system, or it may be of your interconnected system. So this now we are going to see that what is the connection scheme of our distribution system. What about our connection scheme of our distribution system? So any doubt up to this point? Do you have any doubts? Samir? Samir? Do you have any doubts? Shall we proceed to the next topic? Okay. Whether the presentation is visible? The scheme of connections, when it comes with respect of the scheme of connections, the scheme of connection is maybe of your radial system or ring main system that is going to call us of your loop system. Okay, and third thing is going to have your interconnected system. Third thing is going to have your interconnected system. So now we'll see individually what is a radial system, ring main system, and interconnected system, because the scheme of connection of the distribution system is going to happen very, very important for the distribution system. Okay. So what is the often radial system? It's a radial. Remember the name itself, it shows nothing but it's going to be often radial. It means a separate feeder will radiate from a single substation. Okay, that will be remembered from a single substation. So here, remember, just for our clear understanding of expression, I have drawn here is going to of our generation station, but remember this is going to of our substation. Okay. So here, remember, the separate feeders will be radiated from the single substation and feed the distributor at only one end. It means only one feeder will be there. From the feeder, there will be a distributor going to often distribute to the one end. Okay. So, what will happen means the current will be flowing, or power will be flowing only in a single path. Current will be flowing only in a single path. Okay. Suppose if you take with respect of nothing but, suppose I am having a substation. I'm having a substation. So this is going to be of my substation. So this is I'm going to have of my substation. So substation there will be a feeders will be there. So this is going to be F. I'm writing the letter F. F denotes the feeder. Okay. So this is one feeder. F denotes. I have taken OC is going, but this point is going to be of O, and this is going to be taken of C, or maybe a B, whatever. So at this point, a distributor is going to be of an originate. This is going to be from this feeder. This distributor will be there. From this feeder, one distributor will be there. Okay. Okay. So this is going to have a number distributor. DI, I am writing distributor. So in this distributor at this point, so it means this distributor is going to attend denoting number. AB denotes our distributor. AB denotes our distributor. So where this load is going to be often connected, where this load is going to be often connected. These are going to be of my loads. Okay, so these are my load. Okay, so it means a single separate feeder will be originate from our substation, and that feed will be delivered the feed the distributor at only one end. It will be distributed feeds at your one end. Suppose this neighbor, distributor is going to be often feeding from one end. Okay, so and the neighbor there are no need of low voltage. Means there won't be often any transformer will not be there. Suppose in case if they need often low voltage, so here at the distributor side neighbor from the feed originate, so we'll have often transformer will be there where we use often transformer. So that transformer will be step down your voltages, then there is going to be often speed. Okay, so here in this radial distribution, suppose if there is often any fault, suppose as in this going to happen neighbor, here a fault has been occurred. Here a neighbor, this fault has been occurred. When this fault occur at this point, what will happen? So this neighbor, this is house 1, house 2, house 3, and house 4. So if a fault occur at this point, so automatically what will happen when this fault occur at this point, the house 3 and house 4 they are not able to get the power supply. They are not able to get the power supply. Okay, so that number if it interrupt means then there will be a complete loss of power will be there. Okay, but one of the main advantages remember the construction weight is radial distribution will be of low cost and simple in planning. Okay, but when it comes to respect of disadvantages side, okay, the power should be at low voltage and the substation should be located near to the load. It should be located near to the load. Okay, so but the distributor is near to the fault. Suppose here I am taking one feeder. Okay, I am from this feeder I am taking upon one distributor. So after third class or fifth main I am taking another distributor. Okay, another distributor. So here the loads are going to be often connected more means what will happen? The drop in voltage is going to be often more. So here the voltage will be often lesser. So the distributor near to the feeder will have often more or heavily loaded there, and away it will be often lightly loaded or maybe subjected to often voltage fluctuation. Serious voltage fluctuations will be there. Drop in voltage will be there. Okay, so this is one of the main disadvantages in case of our radial distribution system. In case of our radial distribution system. Here. So this is a radial distribution system. We'll have the substation. So from the substation, we'll have the feeders will be there. So this denotes your feeder. This denotes your feeder. Okay. So this is one of the distributor. This is going to appear one of the distributor. So likewise, in the OC, we'll have another distributors will be there. Another distributors will be there. You can see, but if I take, I can connect another feeders at this point. At this point, I can connect another distributor. Okay, where I can tap some loads. I can tap some loads. Okay. So here, compared to this node point, if you take this node point, the voltage will be lesser. Voltage will be lesser. Suppose if the load is going to be more at this distributor point, the drop will be often more. So automatically the AC line will have often lesser voltages. So, but as per the distribution system, we have to maintain the voltage often plus or minus. Within the plus or minus 6% value, we have to maintain the voltage often constant. So that's why we can have often nothing but transformer at your distributor. So where we will have often distribution transformer will be there, where the voltage is good. Step down to open from 11 kV to open either 400 voltage or maybe often 230 voltage. Okay, so remember and that transformer will be boosting the voltage at that local value, at that local point. Okay. So this is our radial distribution system. This is our radial distribution system. Okay. I can show so much of generator. Then from the generator, I can take taps often the single wire. It originates from that one. I can tap so much of loads. So that is going to have called as of your radial distribution system. That is going to call us of our radial distribution system. Next thing we are going to see about our ring main system, or maybe called as of a loop system. Ring main system, or it may be called as of a loop system. As it denotes the name, the ring or maybe as a loop. So where remember we have from two or more paths will be there between the source as well as the right? Source as well as of your consumer. So loop circuits will start from the substation bus bar and make the area to be served, and then again that loop will be returned to of your substation. That loop will be returned to of your substation. Okay, it means here, so it will be starting from the substation. It will be starting from the substation, and the feeder will be originating. That feeder again will return to of your substation. Okay, so what happened? They will connect so much of distributors will connect it at the distributor. We connect the various distributors. We connect the various distributors. Okay, from the various distributors, we'll have often transformers will be there. We'll have often transformers will be there, which is going to have to step down the voltage. From the transformer, nothing but we'll connect the distributor to of your service mains. We will connect to of one service mains. People, if you see here, this will be your feeder. This will be of your feeder. So this feeder will be originated from the substation, and that will end at the substation only, and that end will be in the substation. So this will be the callings of our primary ring. So this we are calling of your primary ring. Okay, so from that we'll have a fund distributors will be there. From there will be we are counting up a distributor. How the distributor is going to have connected means we'll have a fund distribution transformer will be there. So we'll have a fund distribution transformer. From the distribution transformer, the distributors will be there. So in the distributors, we are going to tap the loads. We are going to tap the loads, and the service mains will be there. Okay. Similarly, here also we'll have a fund transformer will be there to shut down the voltages. Then we'll connect our loads in the distributors. Okay, so this type of system that is going to be called as of here ring main system. This is going to be called as of here ring main system. It has its own advantages. It has its own advantages. So there will be often lesser voltage fluctuation. There will be often lesser voltage fluctuation. Okay, and moreover, nothing but we'll have often reliability. We'll have often reliability. Okay, even under any fault is going to often occur, we can able to maintain a continuity in our supply. So that is one of the main advantage in case of a ring main system or maybe of a loop system. Okay, suppose assume here and but I am having a fault. Having a fault. At this point, a fault occurred. At this point, a fault occurred. Okay, assume it's going to happen. Fault occur at this point. Okay, what will happen? But so at this point, if the fault is going to occur, means since this is going to be feeder charged from the station, right? Up to this point, this part of the feeder is going to supply the power. There won't be any interrupt. So after this feeder is going to happen, but it's going to happen supply. So continuity in the supply is going to happen maintained. That's why here it's going to call the software. We are calling it often more reliability or flexibilities will be there. Okay. So less conductor material will be required, and there will be often less voltage fluctuation will be there. That's what but we'll have often each transformer, distributor will have its own transformer will be there. So that the voltage is going to often maintain more or less is going to often constant. Okay. But that may be differ. How about the distributor? That whether the distributor is going to be fed with one end or it may be fed with two ends. Based on that, the voltage variations will be there. Okay. So the main disadvantage in case of here with the but ring main systems, but that design, but the complexity will be there in the designing the ring main system compared to of your radial distribution system. Compared to of your radial distribution system. Okay, here. So the substation is there. So we are having up the substation. From the substation, the original feeder will be near loop. So this is going to a for loop. So design in a form of loop. Okay, and it will end start with S, and again it will end with respect of S. Okay, SL is one of the feeder, and LM is another feeder, MN is another feeder, NO is another feeder, OP is another feeder, PQ is another feeder, and QR is another feeder, and RS is going to be another feeder. Okay, which forms a complete loop or maybe a ring. Complete loop or maybe a ring. Okay, so we can tap the energy. So the distributor will be tapped from at any point of location of your feeders. Okay, before tapping, we'll have of your transformer will be there. That transformer will act as often distribution transformer where the voltage is going to often step down. So this voltage. So this transformer only we can able to see. This transformer only you can able to see in your area. It means near to your home, in your street, or maybe of your next street, you can able to see your transformer. That transformer is going to be called as your distribution transformer. Where nothing but from there when the distributor is going to often originate, and that means service is going to often connected. Okay, so this is going to appear ring or maybe appear loop distribution system. Okay, so next thing is going to our interconnected system. Interconnected system. It means when a system is going to often ring system. So that ring system, see here, this is our ring system. No, this is our ring system. This is our ring system. So what is the interconnected system? Means where our feeder is going to be energized by various sources and can connect upon two sources. Okay, this is going to be my own source. So you forget this point. So just time being, you forget this one. Okay, I'm not having a substation. Okay, so I'm only thinking about only with respect of my ring main. Okay, in the ring main, if two different sources are going to often supply the power, two different sources going to often energize your feeder. Okay, then that is going to call the software interconnected system. That is going to call the software interconnected system. Okay, so it means supplies by a number of feeders. The radio primary feeders can be tapped off from the interconnecting type feeders. Okay, so it means this is going to have an interconnected type feeders will be there. So what will happen? It will increase the reliability of your supply, losses will be lesser, and the quality of service is going to improve. Why? Because but how much amount of power is needed, that can be easily able to tap it from your feeders. Okay. Here, one of the main disadvantages in case of using this type of interconnected system is nothing but initial cost. Initial cost is going to be often more. Difficult will be in the planning, design, and operation of our interconnected systems. Okay. See here. So this is our So this is our feeder. This is our feeder. Okay. So this feeder is going to be often energized by more than one source. It is going to be often energized more than by often one source. Okay. So S1, S2 are your sources. Okay. So what is the main advantage here is nothing but it will increase your service reliability. It will increase your service reliability. Okay. So it means that if this type of system normally it will reduce our reserve capacity, okay, and it will be increasing our efficiency. It will be increasing our efficiency. If any area from one generation station during a peak load cannot able to feed this from the other generation station, it will be feeded. So that is one of the main advantages in case of our interconnected distribution system. Interconnected distribution system. Okay. So we have seen, but till now we have seen about what is the distribution system. Till now we have seen about what is the distribution system. Okay. So how we can, what is the distribution system? How we can able to classify the distribution system? So based on the nature of the current and type of connections or scheme of connection, nature of scheme of connections, and your type of cable, maybe of an underground cable or maybe a throughout transmission, we can able to classify your distribution system. Okay. The main thing here is nothing but what is required for often any good distribution system? What is the requirement of for often any good distribution system? So what is the basic requirement to have often good distribution system? If you see that good distribution system, so this is one of the examples where I can show how about your interconnected system. Okay. So main thing is going to be our requirement of a good distribution system. Good distribution system means it should have often proper voltages. It should have often proper voltages. Need often proper voltage is going to be often needed and nothing but the availability of the power demand and our reliability. These are the main three important things is going to be often needed for a good power system. So it means if you want to maintain the consistency in your power supply, which is going to ensure means, but we need a power demand should be available. It means how much amount of load is there. For that load, we need to generate the power and that should be supplied. So that's why here remember for a good distribution system, for a good distribution system requirement. So first thing is going to be of power availability of our power demand. Power demand should be available. It means the generation should be higher than your demand. So then only we can be able to supply your requirement, or more or less it should be equal to of your demand. Okay, proper voltage. I told you that the voltage has to be maintained. So remember the standard value. Sometimes some of the books is plus or minus 6%. Some of the books is plus or minus 5%. Okay, so to have an efficient operation of our distribution system, the voltage has to be often maintained. So that voltage should be within the acceptable limit of plus or minus 5% or 6% value. So behind that, below that, it should not go. So then it will affect the efficiency of our distribution system, even the equipment of all the consumer. So that's why here remember the voltage has to be maintained at often constant voltages in the distribution system. Okay, so that we can improve the efficiency of the line as much as possible. Okay, and nothing but the safety as a consumer point, we can give often safety. Okay, so that's why the layout should not affect our appearance of our locality or maybe of the area. Okay, so that's why where we remember in the metropolitan cities, where remember the remember overhead system is not going to be often possible, there we will go for often underground system, so that remember will be often very easy for laying and as well as distribution is going to be often easier. Okay, and that's why here remember in the metropolitan cities we won't go for overground. Yes, remember densely populated area. Densely populated area means remember the underground remember overhead and lines will not remember you will have often remember more interference with your system. And remember the communication interference will be more. And remember possibilities of frequent faults may be occur. So that's why here remember the metropolitan cities are densely populated. We will try to go for often underground cable for distribution also. Okay, and for the good distribution system, the load should be line load should not be overload, or the feeder should not be often overload. So these are the basic requirements for often any good distribution system. For often any good distribution system. Okay. So here we are going to come for often nothing but the main thing of our type of distributors. I told what about but in the distribution suppose but I think in the first slide we have seen about our we have discussed about our distribution. Correct? We have discussed about our distribution system. There we have drawn the distribution system. Okay. So where nothing but the feeders is going to often argue, then the distributor is going to often connect. Okay. So here remember the distribution system, this feeder, distributor, and your service fee. So that is going to happen very, very important. So the design of a good distribution system is going to happen depends on these three things. Okay, so that's why the distributor. So we'll have often substations will be there. From the substation, this is your substation, SS. Okay, feeder is going to be of an originate. So in that feeder, we'll have often distribution transformer will be there. Distribution transformer there. From the distribution transformer, this is going to be of the distributor. So the distributor supplies your the load or maybe a connected to of your service main. That is going to be connected to of your service main. Okay, so how this distributor, all the different types of distributors are there. Okay, so how the loads are going to be connected in our distributor. So then, but based on that, our DC distributors, DC distributors, we'll have of an AC distributor and we'll have of an DC distributor. If we take up on DC distributor, types are based on the type of load. Because this is going to we are calling support loads. So this is going to call a support load. So based on the load, the distributor may be of your concentrated load or may be of your distributed load. They have often concentrated load or it may be of your distributed load. Okay. If you have often concentrated load means that we can able to feed it one end or maybe often we can feed it both the ends. We can feed it one end or we can feed it both the ends. Okay. So if it's going to be often feed at both the ends means suppose this is a distributor. This is a distributor. I think this is going to be of my distributor. Okay. So this distributor here I am feeding at one end. The voltage is going to be fed at one end. Okay. So that is going to be often fed at one end. If it's going to be often fed at two ends, I am going to feed at both the ends with the distributor. So this is going to be often feeder at both the ends. So when feeding at both the ends, so this feed voltage may be even or may be different. This is going to be often V2 or this may be often V1 voltage. So that's why here remember the DC distributor can be classified based on the concentrated load or distributed load. If it's classified on the concentrated load means that may be feed at one end or maybe at two end. Okay. If it's fed with two end, it means both the ends means that maybe the voltage may be equal or it may be of your unequal voltage. The same thing here is applicable for your distributed load also. The same thing is going to be applicable for your distributed load. So what is mean of this concentrated load? What it means? What it means this concentrated load? So it means acting at the particular point of the distributor that is going to be called as of your concentrated load. Or if the load is going to be nothing but spread out through the entire distance of your distributor, then that is going to be called as of your distributed load or distributed load. Okay, so first here we're going to see these things. Okay, so we have classified what about our distributor systems. We have classified what about our distributor systems. So DC distributor may be classified based on the loads. One is going to have a concentrated load, other one is going to have a distributed load, and both the things may be fed at one end or maybe on two ends. If it's going to be fed at one end means how about your voltages? That may be an even voltage or it may be an uneven voltage. Even voltages or it may be of a uneven voltages. Okay, so here remember, so based on that I am taking off on one feeder type of distributor. That remember that is going to I am going to take off on distribution is going to off here. So here I am going to take off on distributor loads. I'm going to take off on first example. I am going to take off my distributor. So here we are going to discuss now everything we are going to discuss with the distributor load. So if you understand this, then we can able to do it for your concentrated loads. So here important thing is nothing but you have to know about your Kirchhoff's current law. What is your Kirchhoff's current law? Anyone said the law? Said the Kirchhoff's current law. Jivita? Jivita? Ashwin?
Yes, sir.
Voice break ಆಯ್ತಾ?
Starting now, sir. Sir.
Okay. So state Ohm's law. Sorry, Kirchhoff's current law.
Current law. The current flowing through the circuit.
Sir, sum of entering current equal to sum of leaving current, sir.
Yes, very good. Algebraic sum of the current is equal to often 0 at any node. At any node, algebraic sum of the current is equal to often 0. In other words, we can say that algebraic sum of the entering current is equal to often algebraic sum of the leaving current at that node. Okay, we have to speak about the node. Okay, so at any node or junction, the algebraic sum of the current is equal to often 0. That is your Kirchhoff's current law. It means nothing but algebraic sum of the current entering at that node is equal to often algebraic sum of the current leaving at that node. So that is going to often remember that law is going to often very important for analyzing of your distribution system or your distribution system. So here the following distribution system I have taken. One is going to be of fed at one end, fed at both the end, fed at center, or it may be of your ring distributors, or it may be of our ring distributors. Okay. So if it's going to be of fed at one end means nothing but the voltage is going to be power is going to be feeded at only one point. It will be feeded at only one point. So this kind of supply will be connected at one end and the loads are tapped at the different point along with the length of the line. The load but one point of supply control. This is going to affect complete this going to affect distributor. Okay. In this distributor, the loads are going to often tap the energy. Okay. So tapping your energy. Okay. So here nothing but if it taps the energy at this point, okay, the current will be varying in the each section of our distributor. So and the voltage may be of but sometimes the voltage at the C point is going to be of maximum. At the E point, this voltage may be of your minimum. Okay. So here in the current in this section, if you see here in this section, remember the current is going to often varies in this section of the distributor from the feeding end. Okay, as the remember at the last point, if you see at the end of the remember feeding point, remember the current is going to often decreasing. Why? Because more load will be often connected at the starting point. Okay, so as well as the voltage as it goes, the voltage also is going to often decreasing from the feeding point. Okay, so it may be nothing but as per the diagram I given here, this is the V is going to often nothing but V is going to call us of here maybe of your minimum potential voltages. Okay, so here in this point, if any fault occurs in the distribution, the whole distribution system will be disconnected from the supply and the continuity will be often interrupted. Continuity will be often interrupted. Okay, so this is going to often happen in case if a distributor is feeded at one end. Distributor is going to often feeded at one end. So normally, so they will give often this distributor, they will give often this type of feeder. They have to calculate at which point is going to have the minimum potential point. At which point, remember, they will ask to calculate the minimum potential point. So if you want to calculate the minimum potential point, so this is a feeder. Feeder means, remember, suppose this is a feeder. Okay, this is your feeder. Okay. So this is my load. I'm tapping the load. Okay, this is my, so this is your feeder. I'm tapping my load. Okay, load 1, load 2, load 3. So this is finally, but so where the power is going to be feeded at this point. Okay, so this may be from V. Okay, V is applied at this point. At this point, the voltage is going to be the power is going to be supplied. Okay, as it supplies, the current will be flowing through our circuit. Our current will be often flowing through our circuit. Okay, so that's nothing but here the current and this from this point the current is going to often alternate. Since there is often tapping, current is going to often divide at this node point, the current is going to often divide. Okay, again at this point, again that is going to often divide. Again at this point, this will be often divide. Okay, So I know the low value. If I know the current value, then I can able to calculate what is the potential at this node. I can able to calculate what is the potential at this node. This C at this point C, D, and E. I can able to calculate what is my potential. Then based on the potential, I can able to calculate which point is going to be the minimum potential point. So it means I have to apply my Kirchhoff's current law. Then I have to calculate what will be of my the potential. Okay. So this is going to be a distributor if it's fed at one end. The same thing if it's going to be fed at both the ends. Suppose I'm given this is going to be fed by both the ends. So this is one feeding point and the B point also is A and B both are going to be feeding point and that is going to be called as of a distributor which is fed with both the points. Okay. So it means nothing but the voltage occurs at some load point will be of the minimum voltage. See here in this previous point, see here in this one, but that means there is no supply at this point. Since there is often no supply, since there is often no supply point at this point, so this became of minimum voltage. If I am supplying at this point also, this minimum potential may be fixed at this to this D point or maybe a C point. Depends upon the load. Depends upon your load. So that remember that is going to often happen only in case of when the distributors are fed with both the ends. Okay, may or may not be equal. Which one? These voltages may or may not be equal. So it may be often different. Then that is going to call the software distributor fed with equal voltages or distributor is going to often fed with unequal voltages. Okay, so here remember that's why here remember the minimum voltage occurs at some load point which is fixed with the variation of load on the different section of the distributor. These are different loads on the section. So based on that, that minimum potential point may be fixed to D point or maybe up here E point when it's going to appear fed at both ends. So what is the advantage when the distributor is going to be fed with both the points means nothing but right. If the fault occurs, any feeding point may be often distribute the power. Any feeding point which is able to distribute the power so that the continuity of the power supply is going to be often maintained. Okay. This is our feeding at both the points. Okay. Suppose in case if the distributor is going to have fed at center, so nothing but that is going to have called a center point of feeding. So this is nothing but you can see here nothing but the load is going to happen. This is going to load is going to happen supplied at the C point. So this is going to have supplied. This is going to happen B. This is going to happen B. So automatically what will happen? This is going to have nothing but suppose assume this is going to have my I1 load. Okay, this is my I2 load, right? And here I3, and this is going to appear I4. So automatically from the feeding point, the current at this point is going to happen I1 plus I2, where the current leaves at the node is going to happen I1 I2. So entering will be happen I1 plus I2. Similarly, from this point, the current entering towards the B point here is going to happen I3 plus I4. Okay, so what will happen here? Nothing but the last load may be leads to, but we have often voltage drop. We have often voltage drop in the both the sides of your distributor. In the both the sides of your distributor. Why? Because we are feeding at the center point. So automatically what will happen when the number feeder length is going to happen more. When your feeder length is going to appear more, okay. So this point may be leads to have often more voltage drop, and as well as often this point also will lead to have often more voltage drop. So that is one of the greatest disadvantage in case if the distributor is going to often feed at both the points. So normally that is going to often preferred to have often equal length. So suppose 1 kilometer length is the midpoint is going to appear 5. Okay. So ring main system. So then remember the loop system will be there. So closed loop ring will be there, and remember from that we can take any number of feeders or maybe a load. So that's going to often refer going to appear ring main DC distributor systems. Okay. So how we are going to calculate the values? How we are going to calculate the values? if you want to design a DC distribution system, means you have to calculate what is the voltage drop at each and every section. Then only we can able to design a DC distribution system or AC distribution system. So here I have taken nothing but the concentrated load. With the concentrated load, if the load is the distributor is going to be often spread with one end. If the distributor is going to be often spread with one end, Suppose this is going to be of the voltage going to be of V. So what is the voltage drop on VC, VD, VE, and VF? So assume that, so this is the lever distributor. The distributor is going to be the over transmission line. It has its own resistance. Every section I am taking the resistance of the wire. Okay. So we have a but normally for supply, if you want to calculate the current, means it should have a return path, then the current will be flowing. So it means the resistance will have often, but the wires will have often go and return wires. It means one is going to be often nothing but path flow, another one is going to be often return path. Okay. So here AC, CD, DE, EF are the distributors. Okay. So where it's going to often feed the load at each and every point. Feeding point will be of here at but current. It means the entering current that will be of here at A. And the current in the section AC will be equal to often I1, I2, I3, and I4. Okay. I can write it from, but since this is going to be of my but this is a current which is going to be often coming from here. What does it mean? But current from this point. So here I4, I3, I2, and I1 is there. It means the entering current here is going to be of my I1 plus I2, I3, and I4. So that is going to have the entering current. So at this point, it's going to have I1 is going to have leave. So here the current in this section is going to have at this point the current is going to have I2 plus I3 plus I4. So at this point, the entering current is here is going to have my I3 and I4. That is going to get divided at E and F. So at this point, only here and I4 is going to be flowing. So if I know the current in each and every section, if I know my resistance, here I taken R1 is going to be the resistance at the section of AC, R2 is the resistance of my CD, and DE, R3 is the resistance of DE, R4 is going to be EF section. So if I know the resistance and current, then I can able to calculate what is the drop in the section. If we add, that will give what is the total voltage drop. So from that we can able to calculate this is going to be my minimum potential point. This is going to be my minimum potential point for the distributor, which is going to happen fed at one end. Okay, so it means for solving the numerical problem, if you know your Kirchhoff's current law and Ohm's law, then you can able to solve the problem on your DC distributor. So whether it may be fed at one end or fed at both the ends, whatever it may. Okay. So the fundamental laws only we are going to apply. No, there is no such of derivation. If you apply the law and calculate what is the voltage and current, then we can able to say that which is the minimum potential point and which is the maximum potential point, where the load is going to be often loaded heavily. So we can able to analyze very easily. Okay. So with this, so just I will stop here. Okay. So next session we'll solve some of the problems on the distributors. Yes. So we are seeing the distributors, concentrated load, or maybe of your pacifier and based on the concentrated load, or maybe of your distributed load. So that may be fed at one end, or maybe of your both ends. If it fed at both the ends, voltage may be equal, or it may be of your unequal. Okay. So this is what we have to analyze our distributors. So how we are analyzing distributors, we will see in the next session. Okay. Any doubt? So any doubt? Students, response.